this is 3.3. We're talking about parallel and perpendicular lines. We're going to be defining parallel lines, perpendicular lines, and actually finding the equation of them and determining if the lines are either parallel, perpendicular, or neither. So first, let's start talking about the symbols that we have for parallel. If you notice that there's a double L here, so that actually is helpful because that double L in the word parallel is actually our symbol for parallel lines. So they're just two straight lines that look like L's, they never intersect. Perpendicular, the symbol for that is an upside down capital T. That really tells us that the lines meet at a 90-degree angle. So those are the two symbols for that. So if right now, if you want to go ahead and go do these two problems, the warm-ups, and then when you're done, hit play, and we'll come back to that. So the two words that we're going to be reviewing here is reciprocal. Reciprocal of -1/5. The reciprocal is basically reminding you to take your numerator and denominator and flipping it. So the numerator becomes a denominator and vice versa. So the reciprocal of -1/5 is -5/1. And that's it. Or you could reduce it to just -5. So either way. Identify the slope of a line whose equation is 4x minus 3y equals 1. In order to identify the slope, we should put this in slope-intercept form. So it can become identifiable really quick. Because we know that our slope is our coefficient in front of the variable x. So to do that, we're going to go ahead and put this in slope-intercept form. Subtract 4x from each side. We get -3y equals -4x plus 1. Remember, they are unlike terms. Divide every single term by -3. Don't forget that a negative divided by a negative is a positive 4/3, and then I have -1/3. Again, we only care about the slope because that's all they're asking us to do is identify the slope. So our slope is positive 4/3, and we are done. Okay. Next, you may not have this in your notes, but I think it's really important to identify what is similar to parallel lines and perpendicular lines. So we can right now identify what that is. So two lines are parallel. Let's say I have, these are representing my two lines. Two lines are parallel if they never intersect. If their rate of change, if their speed is changing simultaneously at the same time, that means their slopes must be the same. Their rate of change must be the same. Because as soon as one of them's off, what's eventually going to happen is they're going to intersect. So in order for them to never ever intersect, they must be changing at the same pace, always at the same time. So two lines are parallel if they never intersect. And so what has to be the same is their rate of change. And another word for rate of change is slope. So we're going to say, and the slopes are the same. So they're equal. They're exactly the same. So in other words, let's say I had a slope of 2/3. Then the slope parallel, there's my symbol for the slope parallel to that line, must also be 2/3. Okay? Because the slopes are the same, the lines are never going to intersect, the slopes have to be identical. All right, next. Two lines are perpendicular if they intersect at a right angle. So if we look at this, these lines are intersecting, but it doesn't mean that they're perpendicular to each other. So lines are perpendicular if, when they do intersect, a right angle is formed. So for example, the floor to the wall to the ceiling, or even in a bookshelf. The shelf to actually the vertical part of the bookend. So we have to have a 90-degree angle in there. So in order for that to occur, their slopes are not going to be the same. Their slopes, if anything, are going to be something called the opposite So their slopes are the opposite reciprocal. So let's look at that word, opposite reciprocals. While we talked about what reciprocals are, reciprocals you just switch the numerator and denominator, or flip it. The opposite means the opposite sign. So for example, if I had a slope, like this one over here, of positive 2/3, then the slope perpendicular to that line would be the opposite of positive, which is negative, and then the reciprocal of 2/3, which is 3/2. So there is the slope perpendicular to our original line. Okay? So let's look at these examples here. So here we're going to determine whether these lines are parallel, perpendicular, or neither. So in order to define if they are parallel, perpendicular, or neither, we're going to compare the slopes. So compare the slopes. If the slopes are exactly the same, we know they're going to be parallel to each other. If the slopes are opposite reciprocal, we know the lines are going to be perpendicular to each other. If they're neither, then they're going to be neither to each other. So the first thing you need to do with you have line 1 and you have line 2, so you're comparing how this one compares to this one, if they're parallel, perpendicular, or neither. It helps when they're in slope-intercept form, so you can compare the slopes. Since they're not in slope-intercept form, put them in slope-intercept form. So 3y equals negative 2x plus 9. Divide everything by 3. Y equals negative 2/3 x plus 3. So again, all I care about is the slope, which is the coefficient in front of the variable x. So in this line, my slope is negative 2/3. Okay? Back to calculating here, again, I want to put the equation in slope-intercept form. So the y is almost by itself on the right side, so I'm just going to go ahead and subtract that from the right side. And if I switch this around, I really get 9y equals positive 6x minus 4. If I divide everything by 9, and I have to make sure you always reduce, because right now it looks like, oh, well, they're not even close to each other. But you always have to remember to reduce wherever, whenever possible. They both have a factor of 3, so if I reduce that, that reduces to positive 2/3 x minus 4/9. So again, if you compare the slopes, this case, the slope is positive 2/3. All right, let's look at that carefully. This line has a slope of negative 2/3. This line has a slope of positive 2/3. They are opposite signs, but they're not reciprocals of each other. So they're not perpendicular. Also, because they are not identical, they are not exactly the same, they aren't parallel either. So this, we're going to say that the lines are neither. They're neither because the slopes are neither the same, nor are they opposite reciprocals. All right, let's look at B now. Hey, what's nice about B here is that our slope is already identified because our line is already in slope-intercept form. So this slope is negative 7/2. There's really nothing to do there. However, with this one, we do have some minor work to do. We're going to go ahead and put that in slope-intercept form. So if we subtract 4x from both sides, negative 14y equals negative 4x minus 5. Divide by negative 14 to each and every term. Make sure you reduce. So if we reduce here, this is going to reduce to positive 2/7 x plus 5/14. Okay, and again, all we care about is identifying what that slope is. So our slope here is positive 2/7. So comparing that, positive 2/7 to negative 7/2 with our first line, you can see that they are opposite signs of each other and the reciprocal of each other. So because they are opposite reciprocal, we are going to say that the lines are perpendicular because slopes are the opposite reciprocal. And that's it for those. All right, let's look at C. It would probably be a good idea first to put this in slope-intercept form, and we can get rid of this fraction here right now if we multiply everything by 3. So this would give us, reduces to 8x minus 18y equals 0. And if I get y and isolate that by itself, if I subtract 8x from both sides, let me bring this down a little, we're going to get negative 18y equals negative 8x. Sorry. Divide by negative 18, we're going to get y equals, again, reduce, they can be reduced by a factor of 2. So I'm left with positive 4 9 x plus 0, but you don't need to write the 0. So again, this is nice because our slope here is telling us that our slope is positive 4 9. So if we compare that to the line number 2 here, we have to put this in slope-intercept form. We're going to get negative 9y equals negative 4x plus 2, divide by negative 9, every single term. Y equals positive 4 9 x minus 2 9. Again, all I want to concentrate on is that slope. Notice that the slopes are identical, and since the slopes are identical, we know the lines must be parallel. So, lines are parallel. Change the thickness of that because slopes are the same. Okay? And if we go ahead and look at our next example, they're asking us, hey, what about a line that contains these points and a line 2 that contains these points? Well, because all we have to do is compare the slopes, we're just going to go ahead and calculate the slope for each of these lines. So remember, your slope formula is your change of y divided by your change of x, which compares the difference of your y values in the numerator. So the difference, like I always say, put that shell there. So the difference of my y values is negative 9 minus 3 over, divided by 4 minus negative 2. And as always, simplify wherever possible. Here I have negative 12 in my numerator. 4 minus a negative 2 becomes a 4 plus 2, which is 6. So this slope is negative 2 over 1, or just negative 2. So the slope of line 1 is negative 2 over 1. Let's compare that to the slope over here using the same formula for slope. Change of y divided by change of x. We know that we're going to have our minus sign there, and from there all we're going to do is fill in our y value subtracted, so negative 4 minus negative 6, and then 1 and negative 3. Here I can simplify that to minusing a negative becomes a positive, so negative 4 plus 6 is positive 2, and then 1 minus a negative 3 is plus 4, which reduces to positive 1/2. So the slope of this line is positive 1/2. So comparing line 2 slope with line 1 slope, see if you can determine whether or not those lines, how they compare. Are they parallel, perpendicular, or neither? Okay, so they're opposite and they're reciprocals, so this is perpendicular. Lines are perpendicular because they have opposite reciprocal slopes. All right, let's look at number 2. Find the equation of a line with the given properties. Express the answer in slope-intercept form, which of course is y equals mx plus b. But to do that, we're going to use point-slope form. So look here, they actually gave you a line, and they want you to find the equation of the line. You're like, why are they giving us a line then? What use is that? Do I just take this point and put this in here for my y-intercept? You do not. The only reason they gave us the line is to use the slope that's parallel to that. So parallel means I'm going to have equal slopes. So all you needed then to do was steal the slope of that line. So what I'd like for you to do is identify in your work here what the slope of the original line was they gave you, which is -3. Since they want a line parallel to that, I would like for you to write this. What's the slope parallel? Well, you know that parallel lines have the same slope. So it's going to be the exact same, -3. So I would like for you to box that, highlight it. So the only reason they gave you this was to steal it so you could use that -3. Now they gave you a point. So remember that this is your x1, y1. And we're going to use point slope form. If you forgot what point slope form is, remember it's y minus y sub 1 equals m times x minus x sub 1. And you are substituting in for y sub 1, your slope, and x sub 1. So you're using this point and the slope parallel to that and substituting in those values to find our new equation. So we are going to do pure substitution here. So y minus, and so in place of y sub 1, I'm going to put in my -1, and then in place of m, I'm going to use the -3. In place of x sub 1, I'm going to put 5. So then all we're going to do from here is simplify. So here I could simplify this to y plus 1 equals distribute, -3x plus 15. And then you're going to put this in slope-intercept form, which is you have to isolate the y. So if I go ahead and subtract 1 from each side, y equals -3x plus 14. So here is my new equation of a line using this point and the slope parallel to this original line. All right, next. So underline keywords here. So again, parallel. So we have to find the slope of this line that they gave us and then use this point. So the slope depends on the equation in slope-intercept form. So we really should get this in slope-intercept form before we could steal its slope. So if I subtract 12x from each side, I get 10y equals -12x plus 5. I'm going to divide every single term by 10. So y equals, now this can be reduced by a factor of 2, so I'm going to get -6/5 x plus 1/2. So the slope of this line here, the original line, is -6/5. So the whole point of us getting that is to figure out what slope do I want to use. Well, according to this, you want a line parallel to that, which means the slopes have to be equal. So that means the slope parallel to that is the same exact slope, which is -6/5. So we are going to be using that -6/5. And we're going to be using this point as well. This is your x and y. So using point slope form, I'm going to go ahead and substitute in, again, for these three values here, my point, x and y, and my slope parallel, which is -6/5. So I'm going to go ahead and substitute in y minus 0 equals -6/5 times x minus -15. All right, so now simplifying. Y minus 0 is just y. -6/5 distributed. Before we do that, though, let's clean up what's in parentheses. X minus a -15 becomes x plus 15. So now when we distribute this, we're going to get -6/5 x minus, now if you could cross reduce here, so 15 and 5 cross reduce to, I don't want to say cancel completely, but we are left with a 3 in the numerator and a 1 in the denominator. So this becomes -18. So this would be, we're done because this is my new equation. Another way you could think is -6 times +15 is -90, and then divided by 5 is -18. So there's our equation. we are done with this one. All right, so this is the one where we want to concentrate on. Perpendicular, remember, there's our symbol, means opposite reciprocal slopes. So they give us the equation. Here's the slope, -4/5. We want to find an equation of a line perpendicular to this line going through this point 10, 2. So I think it's always a great idea to write down the original slope they gave you, but then since we want to find an equation perpendicular to this line, the slope perpendicular to -4/5, you got to take the opposite reciprocal, is +5/4. So this is the slope we want to use. So I'm highlighting this. So we're going to use this slope and this point to write an equation of a line using point slope form. So again, I always want to concentrate on what I'm replacing. And I'm going to substitute in for my x and y and slope, 2 for my y, 5/4 for my slope, and 10 for my x. So if I go ahead, bring -2 down and distribute completely, I get 5/4 x minus 50/4. Now 50/4, I could always reduce that. So -50/4 can reduce by a factor of 2 to -25/2. So I can change that right away to -25/2. I don't want to change the color of the pen. All right, so if I add 2 to both sides, I'm going to get y equals 5/4 x plus 2/1 on -25/2. Really, your denominator ends up being, your least common denominator ends up being 2. So I have -25/2 plus 4/2, which is -21/2. So here's our new equation. All right, next, perpendicular. So perpendicular means I have to have opposite reciprocal slopes to this equation going through this point. Again, we don't even know our slope of our original